Hi, everybody. Welcome to week 5 of our tour of Orgoland. What? What part of Orgoland? What do you need to do? What?
If there's a place you gotta go, I'm the one you need to know. I'm the map. I'm the map. I'm the map. If there's a place you gotta get, I can get you there, I bet. I'm the map. 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 I'm the map.
Okay, a little too much map. But actually generating a map is a great idea if you're trying to travel around Orgoland. And so as we start with lecture 19a and start diving into chapter 10, we really are going to be exploring Orgoland and all of its little suburbs and towns. So we'll be looking into Alcohol City to begin with, someplace that's comfy and cozy, someplace we visited a lot already. But I hope you're trying to at least organize your thoughts somehow, and a map is one way to do it. So I've shown you maps before. Here's another one that I'd like to show you. And this one was written on a whiteboard in the Science Center before the renovations took place. And the student was very excited about generating this Orgoland map of hers. She did it the night before the final exam, and I had given her permission to sit and use this whiteboard map for her final exam the next day. The only issue, a little bit of sadness, a little bit of joy, good news, bad news here, sorry. She showed up the next day and the custodians had erased the entire whiteboard. And she like just totally broke down. You can imagine the stress of all this Orgoland stuff. Luckily, I took a picture of it. Here it is, and I sent it to her, and it all ended beautifully. So let's try to generate an Orgoland map that you will not get erased on a whiteboard, but is yours permanently. And you can see they don't have to be pretty or perfect. They basically have to be yours. You know where everything is. You know where all you're putting all the little cities. And you can see right away there is a big, huge area here of alkyl halides and alcohols. And then there's a big, lots of arrows coming off alkenes. And then we have other little suburbs and other little towns. So this is what chapter 10 and 11 are going to be about, essentially the rest of the term. Let's spread out our Orgoland map and see how many places we can get to. So let's start off with traveling to Alcohol City. This is going to be really nice because it's a comfy place. We've been here before. We've seen how to make lots of alcohols. So let's just skip this tour. And that's okay, maybe. All right. A little review. So how would you synthesize these alcohols from these alkyl halides? See if you got this in your brain. How about these two? What would you do? Pause and take a second and write the reactants that you would use to produce these two alcohols. Okay, this is what I would hope you would use. I would start again with an alkyl halide that has 4 carbons, and pick your favorite alkyl halide. Bromide is my favorite. Doesn't have to be. And then this is on a primary carbon, so I can go ahead and use this nice strong base like OH minus, and I can create this SN2 reaction in, I can pick a solvent if I want, like water, doesn't even matter. I could throw in heat to help the reaction go, doesn't even matter. This is a big SN2 reaction. We'll easily make this alcohol as my major product. So how about the second one? I have my final alcohol on a tertiary carbon. So I should start with my alkyl halide on a tertiary carbon. And that's the easiest thing to start with. Now, being tertiary though, SN2 is not the way to go. I think SN1 is preferable with tertiary carbons, and therefore alcohols that are made in SN1 fashion have to use very, very polite, non-aggressive, weak versions of the OH minus, and that would be water. So basically putting water and this tertiary halide, and to make sure that I avoid the disastrously plaguing ever-present E1 reaction I would make sure I would write room temperature on here, or 0 degrees Celsius, to make sure I tell the reader, do not heat this. I do not want elimination. So here's how I would make my primary and my tertiary. How would you make this secondary alcohol? Pause, take a second. What would you use? Oh, hopefully this one was a little more. You look again. Look what you wrote. I don't know. This is what I would start off with in the same, oops. Take that carbon away. In the same vein as the others, put it on a secondary bromide. Cool. Now, from what we see over here, the OH minus and water are our favorite reactants to produce our alcohol. If I use water on a secondary carbon, I'm trying to do SN1, it sort of works, but not very well. I don't get very much product because it's on a secondary. It's not the most favored carbocation. So I hope that one's the one you used, because if you wrote OH minus, as soon as you use this strong base on a secondary carbon, this immediately forms the E2 product. And so it's bad news. So if anything, maybe SN1, but I hate SN1. Can't control the carbocation, rearrangements are possible. So what's another way I could do this reaction without using SN1? There's gotta be a way. So let's go explore ways that we can do this. And from now on, every lecture will start early somewhere, helping you identify the beautiful sites that you're about to see. Remember these places? We used to be able to go to these places. Soon you will be back. But this is a table that'll show you at least what sections to find all the chemistry we're talking about in each lecture. So you can go explore it in the textbook. And I'll also remind you that, yes, we have seen some of these before. We saw these back in the chapter 8 nucleophilic substitution section. So the only one that is new this week is this reaction. This is how we will take our secondary alcohol and make it into a secondary alkyl halide and turn it into a secondary alcohol in high yield. It's called ester hydrolysis. Fancy name. It's okay, you don't need to know the names, but understand that there's something very different, because I can't use OH minus because I'll end up getting these awful major elimination products. Oof. And so we can't go this route. So what is the solution? The solution is, let's use something that can become an alcohol after we add it. Very much like the mesylates and tosylates that made alcohols better leaving groups so we could do different chemistry with them. What we need to do to make our secondary alcohol is use something that acts something like OH minus, but is not going to cause E2. So we can use what is called an acetate. And this acetate ion looks a lot like the O minus, but is not as strong a base. So it will add only in a nucleophilic fashion and only add to our alkyl halides in an SN2 fashion. And we've seen this before. This is how we make our esters. So that's what we'll try to do. And then a second step will come along that I'll show you in a second, where we can change this acetate back into an alcohol without having any chance of an elimination reaction taking place. So again, to turn our secondary carbons into secondary alcohols, we have to do a couple steps. Sorry, but it works really well. Okay, so here's the beginning. Start with your secondary alkyl halide. And I'm using alkyl halides here a lot, but I'd like you to know you really could have any leaving group here at all. This doesn't have to always be an alkyl halide, just a good leaving group for an SN2 reaction, because we've seen this reaction before. This will react. Oh, I already have an arrow there. Will react in an SN2 fashion, and I just signify that with a little DMF to help point you in that direction with an aprotic solvent, even though it doesn't matter, because this isn't a strong enough base to do E2. It is a better nucleophile and therefore can do SN2. Okay? So once this happens, I have created this acetate, this ester. And so this is step 1. Make the ester. Step 2. Now add OH minus. And you're thinking, wait a second, this is going to do the same thing. Not at all. This carbon right here with the C double bond O and the O bonded to it is very, very partially positive. Much more partially positive than any of these hydrogens or acid-base reactions around this secondary carbon. That carbon is screaming out. So anytime this OH minus comes around this acetate, it falls in love immediately with this carbon. And since that carbon can't form 5 bonds, right? No 5 bonds. Something's got to give. And who's pulling electron density? Well, to tell you the truth, the full mechanism involves the double bond in the C double bond O. So what I'm showing you is kind of a Cliff Notes version of the mechanism, but it's actually going to get you to where you want to go. If I attack with OH minus and form a new bond with that C double bond O carbon, then this bond at some point will fall off and bounce onto that oxygen. And so you will create this negatively charged oxygen, and you will create acetic acid. You will create, acetic acid. And sitting in solution, this acid is sitting around, looking around, and all of a sudden this O minus is a really strong base. And it's like, whoa, wait, I love you. Whoa, man, acid-base reactions in love. So it will immediately grab the proton from the acetic acid and protonate the O minus, making what? Yes, it makes that secondary alcohol and makes a very stable conjugate base that falls off compared to all these stronger bases like OH minus and these alkoxides. This is a much stabler, happier, negatively charged oxygen due to resonance. And you have done a beautiful ester hydrolysis that actually produces a high yield of this secondary alcohol. And notice it's doing an SN2 reaction here. So if there is any stereochemistry, this is where you're going to get the backside attack, not here. Notice the second step is really just the removal of the acetate and the protonation of the oxygen. So all the stereochemical stuff happens in step 1, not step 2. So take home message from all of this. Please, please keep in mind, if you want a secondary alcohol, then the only way to really produce it in high yield is to create the secondary acetate, okay? And so do an SN2 with the acetate first, and then OH minus second. Pretty cool. All right, we're flying through Alcohol City. How well can you do Alcohol City? Try these reactions. See what happens. See if you can come up with the answers to these, okay? Please, please. The only way we learn is by mistakes. So throw your possible answers with who knows what mistakes into our Jamboards this week. And we haven't been getting everybody writing them in. Come early to your Jamboard session if you want to draw them in very slowly with your mouse. I don't care. Let's get everybody participating. That's what it's about, Orgoland tour members. Don't let your tour members just dominate your study groups. Brand new study groups this week. Show off your skills with the Jamboards, okay? If that, oh, that's not enough to play with? Oh, well then let's practice with these. All right, try to tell me which one of these produces the highest ratio of nucleophilic substitution over elimination products. So again, this is kind of merging back into chapter 8 and 9, but also letting you see the chemistry that we've just learned today. Okay, so bring the answers to these from these to class. Please, please, please don't make me beg. Okay, all right. And then we will play with these, and then also the problems that we see in 19b, coming soon to a YouTube video. All right, I'll see you soon. Bye.